I'd like to share with you what the process of building a generative AI software application feels like. Let's take a look. Here's what the life cycle of a generative AI project to build a software application feels like. We would start off by scoping a project to decide what do we want this software to do. So for example, say you decide you want to build a restaurant reputation monitoring system. The next step would be to actually try to implement it. And given the ease of building AI applications using generative AI, which you may have seen in the optional video that came before this one, very often you'll be able to build a prototype quite quickly and then plan to, over time, improve this software prototype. For some applications I've worked on, we would build the initial prototype in 1 or 2 days. And that initial prototype, frankly, isn't that good initially. But building it quickly lets us then take it into internal evaluation, where we might have our own internal team write different restaurant reviews and test the system to see how often it is giving a correct response. And sometimes the internal evaluation will turn out some examples where it doesn't give the right results. In this case, with my pastorless code, it outputs this as a positive sentiment. And sometimes cold pasta is delicious, but this sounds like a negative sentiment to me. And based on problems that we discover internally, we'll then go back to continue to improve the system. As you saw last week, writing prompts is a highly iterative process where you have to try something, see if it works, and then improve it. And building a generative AI software application also tends to be a very iterative process. After a sufficient internal evaluation to give you confidence that the system's working well enough, then we would deploy it out in the wild and continue to monitor its performance. And it would not surprise me if you deploy something and initially external users also generates input that causes your system to make some mistakes. For example, maybe a user writes, "My miso ramen tasted like tonkotsu ramen. Is this good or bad?" Well, if you're not familiar with ramen or with Japanese cuisine, you may not know, is this a good thing or a bad thing? And if your system rates this as a positive sentiment, but it turns out that if you're ordering miso ramen on the menu, you probably don't want it to taste like tonkotsu ramen, which tastes more like pork-based soup broth. And when you find incorrect responses like this out in the wild, you might decide to go back to internal evaluation, for example, to systematically understand if your system is, say, underperforming on certain types of cuisine. Or you might decide to go back to take these learnings to improve the prompt or improve the system further, assuming you decide that these types of errors are unacceptable. So it turns out that building generative AI software is a highly empirical, and by that I mean a highly experimental process, meaning that we'll repeatedly try something and then find and fix mistakes. We've already seen how prompting itself is a highly empirical process, where you would have an idea, try the prompt, see the response, then maybe update your idea in the prompt and go again. But other than updating the prompts, there are other tools that we'll talk about this week for improving the performance of your generative AI system. One tool that we talk about later this week is RAG, or Retrieval Augmented Generation, that gives the large language model access external data sources. We'll also talk later this week about a technique called fine-tuning that allows you to adapt a large language model to your task. And then finally, pre-training models, which refers to training a large language model from scratch. Don't worry about it if you don't know what any of these terms mean. We'll go through each of them in depth later this week, but they're all key techniques that, in addition to prompting, gives you different ways to improve the performance of your generative AI system's performance. Just to walk through a second example of the lifecycle of a generative AI project, let's look at what building a system to take food orders might look like. Say you decide to scope a food order customer service chatbot to take orders. What you would do is start by building the system and quickly throw together a chatbot to take food orders. Then, because we don't know how well this is doing internally, you might let your internal team try it out and place different orders and see how well it does. And sometimes it'll generate good responses, like do you have pickles on that cheeseburger? And it'll ask if you want some. And sometimes it will give an unexpected poor response, such as if you do have mushrooms on your burgers, but for some reason, the chatbot says, I'm sorry, we don't have mushrooms. Similar to what we saw for the restaurant reputation monitoring system, it will be by discovering mistakes like these that helps you to improve the system. And after you're sufficiently confident that this is safe to deploy externally, you can then deploy it and let customers place real orders and monitor the large language model's responses to make sure that if it still says anything it isn't quite supposed to, that you can continue to improve its performance. Having built a number of generative AI projects, I've often been surprised and delighted by the strange and wonderful things that the users will try to do with your system. For example, if a user asks, how many calories are there in your burger? Initially, the system may not know, but if you discover this, you can then update the system using perhaps a technique called RAG that I mentioned just now, and it will go into depth later this week to allow your software application to give a correct answer. So that's what building a generative AI software application feels like. And if you work at a company with a few or a lot of software developers, and if you ever come up with a cool idea for a generative AI application that your company could build, this hopefully gives you a sense of what that process of getting it built might be like. Now, one of the worries I sometimes hear about is it really expensive to use these large language models hosted by companies on the internet? It turns out that the use of these large language models is probably cheaper than many people think. In the next video, I'd like to share with you some intuitions about how expensive it is or isn't to actually use these large language models. Let's go on to the next video.